Open a step file, mesh it, run your FEM simulation and view the result right inside the graphical user interface I built from scratch in C++. To begin, let's load the geometry. You can go to the top menu bar and click on File, Import, and then select the part you want to open. Alternatively, you can open a geometry part directly from the project tree by right-clicking and choosing New Geometry from File. Let's go through improving our UI to not mesh in a geometry right after importing. This has been kept like this from my earlier testings. To correct this, I go to Editor, C++ File, and change the part inside Choose File dialog Import. Inside this, I have changed all GMesh meshing things, and then I have moved them to the tree containing parts, creating a menu item mesh in order to quick check before creating a meshing dialog. After this, I have added a part flag called isMesh, which tells the API to not create a VTK graphic mesh if the part is not meshed. With this, we have fixed our crash. Voila! Now let's improve visibility. Right now, the model geometry, just like the mesh, appears in wireframe mode. To switch to a solid view, we go inside the VTK OCC class and change this. In addition, we changed the transparency in order to see always our mesh. Now let's create a material. Head to the model tree over materials, click on New, and then enter the Geom models, Poisson's ratio, and density. We can also set later the plasticity mode on the same dialog. Here we are running a model using our explicit FEM solver through the UI. For that, we go to Job Create in the tree and select the JSON file which contains the model input. Once selected, we right-click on it and then click on Run. If then we go to Show Progress, we can see the log which is given by the solver. I have to work in order to be refreshed automatically. I'm working also on the post process in such a way we can see our results in this same UI, inside another tab containing results. So, how is the job actually handled in the code? First, when we hit run, the solver executable is launched using a system call. You can see it triggered at the bottom right. Now, I'm currently switching between the FEM and the SPH solvers. The actual one that runs appears at the top left, but we will select which one to use later in the dialog box. After launching the solver, we handle the output log. To avoid interfering with the file that's actively being written, we create a copy of the log file. This copied version is the one displayed in the dialog box, letting us monitor the simulation progress in real time. We can also view our results. Right now, I'm refactoring this part, but you can already see each VTK file generated by the FEM solver. The goal is to have these results load automatically while the simulation is still running. So stay with me, I will be showing the progress step by step as I build it. If you're into FEM, SPH, CFD, remeshing, or just enjoy watching solids get squished by clever math, you're in the right place. I dive into open source solvers, GPU acceleration, and how these methods actually work under the hood. So hit subscribe, or better, hop on the mailing list at opensourcemag.com. No spam, just good stuff. And if you want to support or ask deeper questions, there's always my Patreon. Thanks for watching and happy coding!